Hello, Martin and Ashia.
Hello, sir.
Hello, sir.
Is my voice okay?
Yes.
So, in the last class, we have discussed the power of accommodation. Okay, power of accommodation we have discussed. So basically, these 2 points we should know uh, before studying the defects in the eye. I am having also the defect in my eyes. Okay, I will tell you later. So, power of accommodation uh, studied in the last class. So you should know what is the distant object and you should know what is the nearby object. This thing will be required for today's lecture. So distant for distant object, if the object is distant means far from your eyes, then you can say that from the distant object the rays coming to your eyes are parallel. This one thing you should know. Another thing you should know, nearby object, for the nearby object you will get the diverging rays from that object. Okay, you will get diverging rays from that object. Okay. Okay, so no one will join today. What happened? Okay, so defects of vision. Before that I want to tell you very small general points. You should know what is the far point of an eye. Far point. So basically far point from the eye means at which an object can be seen clearly can be seen clearly actually you should add something else here. Just wait. Okay, so you can write the farthest point at which an object can be seen clearly. The object can be seen clearly. Okay, so this will be your the farthest point at which an object can be seen clearly. So basically this is the point, means how much your eyes can see the means too much to how much distance your eyes can see the objects. Okay, to how much distance your eyes are able to see the objects. So we see the object far from us. We are able to see the object far from us, very, very far from us. We can see the stars also. So basically, the far point of our eye is infinite. We can see the sun. Sun is at an infinite distance. So basically, the far point of our eye will be infinity. So far point of human eye is infinity. Infinity is written like this. Far point means the largest distance you up to the largest distance your eyes are able to see the object, that is known as the far point. Now there is one more point, the near point. So near point is the minimum distance up to which your eyes are able to see the object. Suppose this is the phone, and now at this distance this phone is clearly visible to me. If this phone is here, now phone is visible, but there is some strain in my eyes. As this phone is coming closer to my eyes, the strain is increasing in my eyes. So you can say that near point is the nearest point up to which the normal eye, what eye? The normal eye can see the object without any strain. Okay, so basically for a normal eye, the near point is 25 centimeter. So near point is 25 centimeter, means up to 25 centimeter the eyes can see clearly without any strain in the eye. You can check this by yourself. You can take your pen and put here. Now it's okay, there is no strain. When this pen will be closer to your eyes, you can see that, and you can feel that the strain is increasing in your eyes. Okay, so you can write the nearest point up to which the eye can see the object clearly without any strain in eye is known as far point, sorry, near point. So for a human eye, the near point is 25 centimeter, means up to the distance of 25 centimeter, your eyes are able, for a normal eye I am talking about. The normal eye can see the objects clearly without any strain. If the distance will be less than 25 centimeter, then there will be some strain in your eyes. So near point for human eye. So I am not talking about my eyes or those whose eyes have some defects. Okay, means we will discuss the defect, then I will tell you what are the defects. Okay, so near point for human eye is 25 centimeter. And this near point is also known as the least distance of distinct vision. This is also known as the least distance of distinct vision. So that I am not writing. Okay. So basically, you should know uh, what is the far point and what is the near point. For far point is the maximum distance up to which our eyes can see. Okay, can see. And
Strain, right? Is written there.
hmm,
Which strain?
here
No, the near point. With strain.
Uh, what are what
With
are you
any
saying?
strain, right? It's written there.
Here, far point. For far point, you
No,
are
no,
saying, no?
no, near point. With any strain, it's written.
No, actually, you this will be without any strain. Matthew, very good. Very good, Matthew. Without any strain. Okay. Okay. So basically, range of our eyes to see the objects will be from 25 centimeter to infinite. Okay. So 25 centimeter is the least distance, and infinite is the maximum distance up to which our eyes are able to see. So you can write one note point here. The range of vision of a normal eye normal human eye is from 25 centimeter to infinite. Okay, this is the infinite. I have told you many times what is infinite. Infinite is a very large distance. You can just say that a distance which is very large, like the distance between me and the sun. You can say that distance is very large. So that distance can be an infinite distance. Okay, so write down this. After that, we will discuss the defects in our eyes. Okay, both of you note down. All of the students are absent today. This is F. Uh, this is the farthest distance. Okay, add here distance also. If you will apply your mind, then you can write. If suppose I am a human being, so I can do the mistakes also. We all are human beings, so we can do the mistake. Suppose if I have written anything wrong on the screen, but if you are able to apply your mind properly, then you can write it. Okay, and you can tell me also, like Matthew did. Okay. So here you can see we are talking about the far point. So we are talking about the distance. So here will be the farthest distance at which an object can be seen clearly. So here please add the distance here, the farthest distance. I don't want to write distance because it will be Write down fast. We have only 1 hour in a week. Then also the students are not attending the classes.
Done, sir.
Okay. Arshia written. Arshia, hello. Matthew, is my voice okay?
It's Martin, sir. Yeah. So,
Hmm?
Martin.
Means the intensity is not okay. Okay.
Yeah, it's okay. Your voice is okay.
Now it's okay.
Yes, sir.
Hello, Arshia.
Yes, sir.
Better written.
Yes, sir.
So far point, maximum distance up to the human eye can see the objects clearly. Near point, the least distance up to which the human eye can see the object without any strain. So now we will discuss the defects in the human eye. So basically there are 3 types of defects. Okay, one by one we will discuss. We will discuss what is the defect, what is the cause of the defect, and after that we will see what is the correction of that defect. Okay, like Matthew written.
Yeah, written, sir.
Okay, so now focus on the screen, both of you. Basically there are 3 types of defects. One is myopia, short sightedness, another is hypermetropia, long sightedness, and another is presbyopia. One by one I will discuss, then you will get what I want to say. So see this picture. This girl is trying to see this ship. This is the ship. This girl is trying to see this ship, and this ship is at a very far distance. So basically, this girl is not able to see this ship properly. Okay, not able to see, and so basically, she has some defects in her eyes. Okay, so this girl is having the eye defect. Basically this girl is having some eye defect. That is why this is not able to see this ship clearly. Okay, and this defect in which the person is not able to see the distant object clearly, okay, is known as the myopia or short sightedness. Myopia or short sightedness. Like I am having a myopia. Okay, because distant object I cannot see without this spectacle. Okay, so she cannot see. Distant means ship is at a very far distance, is some far distance. That is why I have told you what are distant object, what are nearby object. So distance ship clearly. Hello, Hamna. Okay. So my first defect is known as the myopia or short sightedness or near sightedness. Name is short sightedness. It is looking like this girl is not able to see the nearby object. But short sightedness is the person is not able to see the distant object clearly in the myopia or short sightedness or near sightedness. Okay. So I am removing this diagram. So we will see what is myopia. I will not see again and again short sightedness. I will not say again and again short sightedness. I will say only myopia. Okay. This is the defect of vision. This is the defect of vision in which a person cannot see distant, distant, distant means far, objects clearly, objects clearly, though he or she can near by objects clearly. Means the distant object he or she cannot see clearly, but the nearby object he or she can see clearly. Okay, like you can take my case. Distant object I cannot see clearly. I can see, but I am not able to see the clearly. But here, this mobile phone and the screen of the laptop, I am able to see clearly. Okay, so this is known as the myopia. And the far point for a myopic eye means a eye have myopia is less than infinity. Obviously it will be less than infinity because he or she are not able to see the distant object clearly. A normal eye, if the eyes are normal, then the distant object he or she can see clearly means the far point of that eye. I have told you, remember what is far point, what is near point. So far point of a normal eye will be infinity. If he or she will have the myopia, then the far point will be somewhat less than infinity. Okay, so far point of eye suffering from myopia is less than infinity. Less than infinity. Infinity. Okay, so this is the myopia. Now we will discuss what is the cause of the myopia. Why there is this defect myopia in the eye. Means there will be some defect in the components of the eye. There are several components: retina, eye lens. There can be a defect in retina also. There can be a defect in eye lens also. Okay, so what is the cause, basic cause of this? Suppose if a person's retina is damaged somehow, so then also he or she is not able to see the images. Okay, so what basic reasons we are writing here? Reasons of myopia. Number one, actually what happens with a myopic eye, the eye length, okay, the eye length becomes thin, okay, or you can say the converging power of the eye lens, the converging power of the eye lens becomes high than normal. Okay, converging power, we have a eye lens now, we have eye and we have eye lens also. I have told you the eye lens, convex lens. In our eye there is a natural convex lens that is known as eye lens. So if somehow the converging power or focal length of that eye change with respect to normal, then there will be some defect. So in myopia what happens, the converging power becomes high of the of the eye. So if the converging power is becoming high, then focal length is 1 upon the converging power, or you can say converging power is equal to 1 upon focal length. So if power is becoming high, then focal length will decrease. So you can say the focal length of the eye lens is less. Okay, so reason of myopia number one is due to high converging power, or high converging power, or you can say less focal length, short focal length, less or short, you can say short focal length of eye lens. First reason is this. Second, this is the reason of myopia. Okay, this is the reason of myopia, and due to eyeball too large. What is the meaning? What is eyeball? There is an eyeball. Now there is an eyeball. I have told you what is eyeball. This is known as the eyeball. What is, why we are saying a ball? Because we are considering this as the spherical, approximately spherical. That is why we are saying this an eyeball. Okay, so when eyeball becomes large, okay, long means the shape of the eyeball becomes long. Okay, so in what is this right now we are considering the shape, and what is the shape? This will be the shape. So the shape of this eyeball becomes long. Okay, so what happens when the shape of this eyeball becomes long? The distance between the eye lens and the retina increased, and that is why the image is not able to formed on the retina, and that is why this is the defect, myopia in the eye. So basically you should remember these 2 points: due to eyeball too large. Okay, now this is another point. This is the eyeball, this is eyeball, and this is the eye lens in the eye, convex lens. Okay, so what happens with a myopic eye? What happens with a myopic eye? Suppose here is some distant object, here is some distant object, here is some suppose this is the person, this is the object, this eye, this is the eye, human eye. This human eye want to see this person, and this person is at distant object. So I have told you what is distant object. For this eye, this object is distant. And what is the distant object? From which light rays are parallel. So basically from this object light rays will be parallel, and these rays will enter in our eye, and we have an eye lens, so and we have this cornea. So there will be the image. So here the image is forming. Here the image is forming. But where the image should form? At retina. I have told you now. When the image forms on retina, then there are light sensitive cells in retina, rods and cones. Okay, and those light sensitive cells, when image formed on retina, get activated and converts the image into the electrical signal, and that those electrical signals are sent to the brain by the optical nerves. Then our brain process the image and we are able to see the image. But what happens here? Here the image is forming here, not on the retina, or you can say in front of the retina the image is formed. And what is this eye? This is an eye having a defect, myopia. So here you can see in a myopic eye, the image of the distant object, this is the distant object I am writing here. Distant object. So okay, so basically this object is distant object, and from the distant object I have told you the rays will be parallel, and this distant object is with respect to this eye given here. So with respect to this eye, this object is distant object. So from this object to this eye, the rays will be parallel. Okay, rays will be parallel. So of these rays there will be the image, or you can say of this object there will be the image, and this image will be in front of retina. And for the proper image, for the proper visualization, okay, or for the proper vision, where the image should form? Matthew, not Matthew, Martin.
It should from in front of the retina. So in the
No, image should form at retina.
Hmm.
I have told you now, when the image forms at retina, for the actually this eye was the normal eye we have studied. This eye is the normal eye. There is no defect in this eye. Okay, we have considered initially. So basically, you should know, if an eye have some defect known as myopia, so the distant object image will be formed in front of the retina. This thing you should know. I want that in front of the retina. You should know. This point is very important. So in a myopic eye, the image of distant object is formed in front of the retina and not on retina. Okay, so write down.
So when I scroll down,
Hmm. Where is Arshia? Hamna, are you writing? Okay, scroll down. Hamna, are you in the meeting? Are you in the class? Scroll down, Matthew. Oh, Martin.
yes, scroll down.
Sorry. You draw this diagram. So, Martin got it. What happens in the eye having the myopic defect?
Yeah, so
Yeah. So why the person is not able to see the distant object? Because the image is forming. Image is not forming on the retina. If only the image will form on retina, then only you can visualize the object, or you can say the image will be clear. Okay. Arshia, hello.
Hello, sir.
Are you in the class?
Yes, I left because of the net.
Why? Is
Net.
there any problem?
The
saying-
video was stuck, so I had to leave.
Okay, so I think Martin, just wait a minute. Arshia,
Okay,
you
sir.
can take the screenshot of this. Okay, actually, I have explained this myopia. Okay, so you
Yeah, I
can
was
take.
there that time.
Oh, you were there. Okay, so you can just draw this diagram. Okay, just you draw, and I am just explaining. So basically, this is the distant object of this distant object, and this is a eye having a defect, myopia. So I have told you in myopia, uh, the person is not able to see the distant object. So this is the distant object. So this of this distant object, the image will be here at this point in front of the retina, not on the retina. So for the proper vision, the image should be on the retina. That is why this eye is not able to see this distant object. Okay, so you can just note down this or draw this diagram. This is very important diagram. Martin, have you completed this diagram?
Yes, I'm completed.
Okay. For example, uh, if this person is near to this eye, if this person will be near to this eye, then this eye is able to see this person. Okay, if this person is near to this eye, means at a distance, this eye able to see that person. Okay, then there the image will formed on retina. So that will be our next point. Okay, basically. So Arshia, make this diagram, then we will discuss
Okay, sir.
the correction of the myopia.
Done, sir.
Okay, so correction of myopia. This correction for the correction of myopia, this diagram you should know. This diagram I will use later. So okay, so this diagram you should know. So basically, this is the point up to which this myopic eye is able to see the object. Why? Because if the object is at this point and image is at retina, means now this eye can see the object. But if the object is somewhere here, okay, this distance is far from this distance, okay, far from this distance, so this person will not be seen by this eye, but at up to this distance, this eye is able to see the image. Okay, so basically this will be the far point of the eye, far point of this myopic eye. And what is the far point? The maximum distance up to which the eye can see the object. So up to this distance f, what is the distance f? Distance between this eye and this. Okay, so I am just drawing this, and otherwise you will get confused. So I am talking about this distance. Okay, distance between the eye. Okay. So up to this distance, the this myopic eye can see the object, or you can say this f point is the far point of this myopic eye, not the normal eye. For the normal eye, the far point is infinite, and for this eye, the far point is less than infinite. So this distance will be the less than infinite distance. Okay, so at this distance, this person is able to, this eye is able to see the object clearly, so image will form on retina. Okay, this point will be used to correct the uh, this defect. Okay, so you should know what is happening here. So if you are placing an object at the far point of this eye, or at a distance lesser than the far point of this eye will able to see the object clearly. But if you are taking the object far from this far point of the eye, somewhere here, then this eye cannot see this object. Okay, so the eye cannot see this object. Okay, but if you are placing the object, suppose here is the this object, this person, so this person can be seen. So what happened when with respect to this object, if we are seeing, for this object the image will be formed in front of the retina. Okay, and okay, so the far point of the myopic eye is less than infinity, I have told you. Now what we will do, we will place a concave lens between the object. You can see this, this is the lens, these are the lens in this spectacle, and suppose I want to see this object. Now here are the concave lenses between, lenses between my eye and this object. So in between, what is lens is there, concave lens we will place. Okay, according, okay, so this will be the correction. Okay, now I am explaining it. Okay, just focus. Basically, there is one object here at, this is the distant object. That this I want to see, this is a distant object that this I want to see, but this I have myopia. This this I have myopia. So as this I have myopia, this I will not able to see this distant object. But what we will do now? What we will do? We will place a concave lens. We will place a, Robin. We will place a concave lens to correct myopia in between the this object that this I want to see, and okay, and this I, between the between this distant object and between the I, we have placed the convex lens near to this eye like this. So what this lens will do, basically from this distant object the rays are parallel. These parallel rays first strike on the lens. Okay, and this lens is a concave lens. So this concave lens will produce a virtual image of this object. Please remember, virtual image of this object at far point of this myopic eye. Okay, now this object will appear like as this object is at far point of this eye. And what I have told you, if the object is the far point, then this eye can see the object clearly. Now this object is appearing at far point. Basically that is the image of this is the original object and this is the image of that object. So if the image of that object is here, so you can see the image of this object. So this image will work as an object for your eye, and your eye is able to see this distant object. Got it, Martin and Arshia?
Yes, sir.
Okay, write down fast. Beta, if you have any doubt, then you can ask me.
So Nikesh,
Scroll down.
yeah, yes.
So basically, correction of myopia, the concave lens placed in front of the eye forms a virtual image of distant object at far point f, here means of a myopic eye. So is it clear, Martin?
Yes, sir.
Martin, have you completed this?
No, sir.
Okay. So Martin now completed.